Hello, everyone, and welcome to Accelerate Your AI with Serverless. My name is Sarah Ford. I am a developer relations engineer at Google on the serverless team. So in this serverless talk, you'll learn about Cloud Run, which is Google Cloud's easiest and most convenient place to run back-end code, written in any language. And you will see 3 demos on how you can incorporate your AI workloads on serverless. So you can think of this session with the demos as a mini buffet, because we're in Vegas, and Vegas loves its buffets. Let's start with an overview of how serverless helps developers. By being in the cloud, you don't manage physical servers anymore, but now you find yourself managing scaling. And you don't want to manage scaling. Instead, you want to focus on what's core to your business, which is your application development. And with serverless, you get performance monitoring out of the box. Here's another way to look at serverless. Here's traffic from a Google Cloud customer website used with permission. Consumer traffic is bursty, unpredictable. So if you're managing scaling, you have to make sure that you have enough capacity to handle the current customer load. For example, you need to over-provision the blue areas with servers that can handle that traffic. But what if your site is mentioned by a famous influencer, as shown by this unexpected spike? How are you going to scale if you are manually managing the infrastructure? Well, one possible solution is to over-provision. But that isn't fun either, because now you're having to pay for all that unutilized resources indicated in the dark blue. Scaling can be challenging if you want it to be cost efficient, because you have to make sure that the capacity closely tracks the demand. Or by letting serverless handle autoscaling, you can pay for what you use. Or to use a calculus analogy, because you cannot have a Google talk without a math joke, think of it as paying for the area under the curve. With Cloud Run, you can run any container on demand without any infrastructure management, no VMs or clusters to maintain. There are 2 types of Cloud Run services, two types of Cloud Run resources, services and jobs. A Cloud Run service follows request-driven scaling, and instances are scaled behind a Google-managed load balancer, providing out-of-the-box URLs and TLS termination. A Cloud Run service has multiple trigger sources, like HTTP2, gRPC, events, and WebSockets. And you get traffic splitting and gradual rollouts. The other resource type is a job. Cloud Run jobs run a container to completion, so they are not triggered by HTTP requests. And Cloud Run jobs can be executed manually or automatically on a schedule. And you only pay while the job is being executed. You will see both types of resources demoed today. There we go. Cloud Run offers additional fine-tuning and auto-scaling. So if you have certain types of workloads, you might want to take advantage of these fine-tuning, these knobs that you can, and dials that you can tweak for anticipated high-traffic events. So by default, Cloud Run spins up an instance to handle serving requests. But if there are no requests, Cloud Run will keep that instance idle for 15 minutes for free before scaling back down to 0. And Cloud Run will automatically scale up more instances as needed based on incoming traffic and current CPU utilization. Now, if you want to keep a given number of instances warm or ready to go to improve latency, you can use the minimum instances feature. You have to pay for minimum instances, but you are billed at a reduced rate. And this also, and then also to be clear in terminology, we define concurrency as a number of requests a single instance can handle at one time. So by default, Cloud Run sets this value to 80 requests per instance. So for example, if there are 5 requests, or 5 instances in an active state, this means that each instance can receive up to 80 requests each. Okay, let's talk billing. Cloud Run service provides multiple pricing options. The default plan is pay per request. This means that you are only charged when the instance is handling requests. It's kind of like leasing a car, but you only are charged while you are driving the car. Now, whenever an instance is put into an idle state, the CPU is reduced to conserve resources. You can keep the CPU always allocated to keep the CPU ready to go. And keeping the CPU always on can actually reduce costs if your service is under constant load because you are able to take advantage of the reduced prices. And if we determine, if Cloud Run determines that you would be better off on the CPU always allocated plan, meaning that you would actually save money with CPU always allocated, you will see a recommendation in the Cloud Console for Cloud Run. All right, so we're going to have 3 demos, and what I'm going to do for each demo is I'm going to have slides that go over the demo, and then I'll go to the laptop, show you the code, and then we'll go back to slides. But for now, if people want to take this photo for the code labs, if you change your mind later, you didn't take the photo, I'm still going to have these QR codes throughout the slides. The reason why I have these code labs is please do not take notes. Everything here has a corresponding code lab. I have step-by-step instructions how to start from scratch on your own in Cloud Shell. Everyone waiting for a few more phones to go down. OK, so I'm just going to still be with slides, and we'll go over an overview of Demo 1. All right. So in Demo 1, you're going to see how you can deploy a Gemini-powered chat app on Cloud Run. So you're going to see 2 things. You're going to see how you can use the Google Cloud Client libraries to handle authentication to Google APIs automatically for you. And second, you're going to see how you can deploy to Cloud Run without a Docker file. First, authentication is handled by a strategy called Application Default Credentials, or ADC. The Google Client libraries automatically use ADC to find credentials based on the environment the application is currently running in. Then ADC uses those credentials to authenticate to the Google APIs. You will see how ADC works in the demo when I use the Vertex AI client libraries to connect to the Gemini APIs. Your take-home message is when you use Google Client libraries, authentication to the Google APIs happens automatically for you. And you're also going to see how Cloud Run uses build packs to automatically create a production-ready container based on your source code in case you do not have a Docker file. Now, if you do have a Docker file, Cloud Run is going to use that Docker file instead of build packs. All right, so now I'm going to go over to my laptop, and we'll see Demo 1, building that Gemini-powered chat app. OK, so I have an app. It's written in Express, so using Node. So let's just run it on localhost. All right. Do I have any musicians in the audience? A few hands? OK. You're gonna like this demo. So C#, is it a programming language, or is it a musical note? That is the question we're going to ask Gemini. So right now, I have the UI coded, and I have it hard-coded for to be implemented. So we're going to add Gemini to this app and see what it says. OK, so first, let's walk through the main parts of the demo. First, we'll walk through the main parts of this code, and then we'll add Gemini. OK, so here, it's an Express app. And then notice here, I'm using WebSockets. Now, this app.listen, this is going to be run whenever Cloud Run spins up a new instance. Then this is the event handler, or the handler for the WebSocket connection. Then when the user clicks send message, this part of the WebSocket code will be called. Here you see question to ask. This is from the user, the text that the user enters. Then if we scroll down a little bit, we see to be implemented is hard-coded. And then I send that answer back. Now, you might be wondering, why am I sending back literal HTML? Well, if we go to the index.html file, and we go up to the top, you'll see that I'm using HTMX, which allows me to dynamically change the DOM without needing a front-end JavaScript framework. And here in this div to update, this is where I'm going to update this div with the message that the user sends, and then the response from Gemini in the chat app. And then in this form, this is the hyperscript that the HTMX uses to connect to the WebSocket when the user clicks send the message. All right. So with that, let's go back to the main app code, and we'll go back up to the top, and we will add Gemini. OK, so instead of watching me attempt to live code and speak, I have created user-defined snippets inside of VS Code. So I'm going to insert this first one, and then we'll come back to this code in a second. I want to just show you where this code came from. So in my .vs code folder, I have a demo1.code snippets. And at the top, you see I have previously written the code that I just inserted. All right. So first, we need to get an instance of the client library for Vertex AI, or get a reference to the Vertex AI client library. And we're going to keep the instance of Gemini that we instantiate. We're going to keep that in global scope. Now, in app.listen that's run the first time that Cloud Run spins up an instance, this is where we're going to instantiate Vertex AI. So first, I instantiate the client library, and then I use it to get an instance of Gemini. So I'm using Gemini Pro model here. Now, you'll notice that the client library wants a project and a location. You can use Google's metadata service to get this. So Google's metadata service is an API that you can call to get the project ID and also the region where it is running. So we're going to go into the helper file that I wrote for this code. So in case you're running locally, either in Cloud Shell or here in terminal, on my laptop, it's going to just return what I've hard-coded. However, if you are running in Google Cloud, then you can call the metadata service, and the endpoint for project ID is here. And then similarly with region. So let's go back to the main code. So now we have the project ID and location, the region. We have our instance of Gemini saved in the global scope. Then in the chat session, we're going to start, when the WebSocket is first connected, we're going to start an instance of Gemini. You gotta love it when the comments are 8 times longer than the actual code itself. So it's like an 8-to-1 ratio there. OK, to keep this demo code short, I am not persisting chat history beyond the current WebSocket. So if you were to deploy this code and Cloud Run tears down this instance, the chat history will be lost. In the code lab, you will use a Firestore-backed Express session to persist the current chat history across instances. So it's not pinned to just one instance. OK, most likely, you're going to have some sort of user ID. You're going to have, like, perhaps Firebase Anonymous auth to use to save the history. My only point with this was to make sure that you consider, when you're writing your code, Cloud Run is stateless. All right, having said all that, we're now going to start the session with the chat session with Gemini. All right, so now instead of my hard-coded to be implemented, we're going to swap that out, and we're going to send message to Gemini. So we send the question or the message, question to ask, the variable, I call it the message from the user, and then we get Gemini's answer and send that back. Now, I need to authenticate locally. Let's say that this is the first time I was doing this. I need to use, I can use ADC, the application default credentials. And I'm going to use my current identity to do this. Scroll up a little bit. So gcloud auth list. And here you can see my demo account is Eraz, my username spelled backwards. And I have already given my identity Vertex AI user role. So now to use ADC, you can run gcloud auth application default login. And this will kick off an OAuth flow that saves an authentication token. So here I select my user. I continue to sign in, and I verify the scopes of permissions and click Allow. And now I'm authenticated. And if we go back to the terminal, you will even see here, these credentials will be used by any library that requests ADC. All right, now I'm authenticated. Now we can do npm run start. And let's go back here. We'll refresh. Now we are about to talk to Gemini. So Gemini, C#. Is it a programming language, or is it a musical note? Any guesses? All right, let's find out. Programming language. I think, yes, I wholeheartedly agree. But what if I'm in guitar class? And in context of guitar class, C# we refer to the musical note, or the 9th fret of the low E. I mean, for 30 minutes, twice a week, it is the 9th fret of the low E for me, but all other times, Gemini, I think, got it right on the first try. All right, so now we know our app works, and we want to deploy to Cloud Run. My favorite command to use is gcloud run deploy, because that's all I have to remember. And anything that needs, like any requirements, like where sources, whatever it is, any required fields or arguments, it's going to prompt me. But what I'm going to do here is use a service account, because I want to demo the principle of least privilege. And just like my identity, this service account has Vertex AI user role. And that will be the identity for the Cloud Run service. So I run that. Source location, I hit enter for a current directory. The name is going to grab it from the folder name, default, demo1 as the default. That's great. And since I previously deployed this, it would have normally asked me, do you want to allow for unauthenticated invocations? But since I previously deployed, I've already said yes. OK, so notice over here, there is no Docker file. It even says building using build packs. But if I had a Docker file, and you will see that later, it will use a Docker file. Okay. So now while that deploys, we'll go over the Cloud Run. We'll go to demo 1. So metrics, like I said earlier, out of the box, performance monitoring. So you can see where I was testing things earlier. Networking, ingress and egress controls. So if anyone is using the serverless VPC access connector, please check out direct VPC egress. It's in public preview. Okay, authentication, you can see where I previously set to allow unauthenticated invocations. Let's talk about integrations. So integrations makes it easier to create resources for Cloud Run services. Instead of having to do step-by-step in the docs, if we were to look at a Cloud SQL here, it would check, do you have the correct permissions, IAM permissions? Do you have the required APIs enabled? And what resources do you need to have created? There's also a Vertex AI one that will do IAM permissions and also check the identity of the Cloud Run service to make sure it has a Vertex AI user role. And with that, this should be deployed by now. Yes. And here is a link you could click directly from VS Code, or we could go just straight to the integration. Yeah, to go straight, like on this page, we'll just click this link. Oops. Yeah, OK. And then C# programming language, musical note, and Gemini sticking to programming language. So that concludes demo 1. So now we're going to go back to the slides, and we'll talk about demo 2. OK, so in the second demo, you're going to see how you can give Gemini access to real-time data using a feature called function calling. Since LLMs lack access to info after their training data, they can seem frozen in time, leading to stale or incorrect responses. Function calling helps address these concerns, or these scenarios, by letting developers pass a description of function to a language model. And to be clear, you as the dev make the function call, not Gemini. We're going to go over this step by step with an illustration. OK, so first, the prompt request for current weather at a given location. So what is the weather like in Seattle today? This prompt plus the function contract for get weather is sent to Gemini. So then Gemini will ask the app to call get weather in Seattle on its behalf. The app makes a call to get weather in Seattle, and it will get back from the API 40 degrees and rainy. Then the app will send those results to Gemini, and Gemini will answer the customer question with 40 degrees and rainy. And I also have this image in the Colab as well. OK, so some use cases, multi-turn chat. You need to run a function in the background. You can tell the user that you're working on the request. Real-time info, weather, currency conversion. Or perhaps you want to make a SQL query on a user's question. OK, we're going to go back to my laptop for demo 2. So demo 2 pretty much picks up right where demo 1 left off. So let's just run. All right, up over here, close that, localhost. OK, what is the current weather in Seattle? And Gemini says, I do not have access to real-time capabilities, and so on. I cannot provide current weather conditions. We're going to change that. Okay. And we're going to let Gemini know of a service I previously deployed called, I should have really named it hard-coded weather, but I called it weather service because so this is a Cloud Run service I've already deployed. It has the endpoint get weather. And I provided 2 locations, New Orleans, I can keep going. Yeah, it's always 90 degrees Fahrenheit, hot and humid, or 37 degrees Celsius. But if it's Seattle, it's going to be always 40 degrees Fahrenheit or 4.5 degrees Celsius, rainy and overcast. Because those are the only 2 weather possibilities for those 2 locations. All right, and so we're just going to curl the Seattle one. I'm wondering if anyone's checking the weather right now on the phone. It is April. It could be that one nice day in Seattle in April. OK, and the weather service says 40 degrees, rainy. OK, so let's give this information to Gemini. So let's go over to this. So this code base, it's very, very similar to what you just saw. We're going to make 2 changes. First, we have to define the function for Gemini to be able to parse. So basically, this is the data structure. And you see the get weather endpoint. You see the parameters, location, degrees, and I can describe it as in Fahrenheit, and also the subjectivity of the weather, how it feels. And then the required parameter is location. And then here, what we're going to do here is we're going to tell Gemini know that this function is available to be called throughout the history of the chat, because only in JavaScript can you comment out in the middle of a line of code. It's amazing. All right, so we're going to let when we start our chat, we're going to pass in the function declaration. OK, and then to scroll back down, so similar code that we saw earlier. This is where it gets different. If Gemini does not need to call a method, it'll just return whatever it was going to say, and it would be just like demo 1. But if Gemini does want to call a function, I log it. Then I, as the dev, as the app, make the request to this weather service that you saw me just curl with the name of the endpoint that Gemini wants me to call, with the location, whatever the user prompt had. Then I get a response object, or well, here. And then I create a data structure for Gemini to know what the response was. I log it if needed. Then this is where I let Gemini know, because Gemini just previously said, call this function for me. So it is expecting this function response parts, like the response to its request. And then we get the answer and send it back to the user. So let's run this. And now, what is the current weather in Seattle? It's 40 degrees Fahrenheit and raining and overcast. The only possible thing it could be. So this is, yeah, so that's function calling. You make the call on behalf of Gemini when needed. So now we'll go back to slides for, that concludes demo 2. We'll go back to slides for demo 3. This third demo is not a Gemini demo. Instead, you're going to see how you can use the specialized Vertex AI APIs to perform specific tasks. And you'll see Cloud Run jobs. A job runs a container to completion and then is torn down. So you'll see how a Cloud Run job can process a video to produce visual captionings for each scene in that video. So in other words, these are text-based descriptions for each scene without any audio. So again, for this demo, only processing the visuals of each scene. There is no audio. All right, so let's walk through what this is. There's multiple steps going on here in this Cloud Run job. So first, the video is sent to the Video Intelligence API to detect each scene change. And so it's going to generate a timestamp for the scene change, as shown here in this array, so 1, 7, 11. Then FFmpeg is used to produce screenshots for each timestamp, as shown here in these file names. For example, scene 1, a timestamp 1 would be video file name 1.png. Then those screenshots are sent to the image text model to produce a visual description of each scene, as shown here in the final output. So in the video that you will see, you're going to see there will be 3 quote-unquote scenes. And for example, timestamp 1 will be a description. What is Google Cloud Vision API question mark is written on a white background. All right, so let's go to my laptop for the final demo. OK. So the first thing to mention in this demo is that this is a Cloud Run job. Notice that there is no web server. It's a job, so it's just going to run this code to completion. Now, I could have used Cloud Scheduler. I could use workflows to trigger this job. But I'm going to manually execute it. And I'm just going to use hard-coded values for demo purposes right now to where my sample video lives in cloud storage. First step is to download from cloud storage the video into the Cloud Run job instance. Then we'll use the Video Intelligence API to get those timestamps like 1, 7, 11. And I have a helper file for that. We'll go into this helper file. And here you see I'm using the Video Intelligence client library. And one thing here is in the request, they refer to it as a shot, not a scene. But for now, artistic license, creative license here, I'm going to use the term shot and scene interchangeably here. And then here you see, this is really the main code. This is like these 3 lines are the main call to say, hey, go get me, for this video, go get me the input content, and for the scene changes, give me the array of timestamps when each scene changes. So I get that, and then I do a little bit of lightweight data processing. For example, I don't want scenes that are shorter than 1 second. I don't want it too close to the beginning or end, so on and so forth. Just because I like the whole numbers in the array. And then let's see. Let's go back to the main file. OK, so we have our array. We have our timestamps. And now we're going to go and use FFmpeg to get those screenshots. So let's go into here. And this is where we're going to use FFmpeg. And the main code is really here. So basically, we're saying for each timestamp in the array of timestamps, go grab a screenshot and save it to this file name, in the output folder. And then when it's done, the promise resolves, and we go back to the main file. OK, so part 3, I wanted to show you how you can still use Google APIs if you don't have a client library. So let's say that you have your favorite programming language, but you can't find a client library. You can still, like for Vertex, like in this example, you're going to see how you can use, you're going to call Vertex AI APIs directly. And the first thing you have to do is get an access token. So here, you can still, so in this example, I'm using a client library for the Google authentication library to get that access token. But let's say, hey, if I don't have a client library for this one, what if I don't have a client library for auth? You can still get it, an access token from the metadata service. So you have options. OK, now let's say you have an access token, whether from this client library or from the metadata service. And what we want to do now is create the scenes, the final output. Okay. So in line 82 here, this is JavaScript speak to say for every timestamp in the array of timestamps, go run this code, which is grab the file, and then send that, the file being the screenshot, and then send it to the Vertex AI API for the vision captioning. And so promise.all, it means run this code for each timestamp and timestamps, run this code all at once, and when they're all done, return the final JSON. So let's go into the helper file to see how you can call the Vertex AI API directly. OK. So here, these are the endpoints, the REST endpoints we're going to call. And I showed previously how to get the project ID. So the header, so the authorization header, bearer token, token being the access token, the image, and then I make the post request, and here you can see the endpoint is to the image text model, and it's going to return the description. All right, so now let's run this job, and that's it. At the and at the bottom, we get our scenes. So I'm just going for demo purposes, just logging out the final output. And with that, I have already deployed in the interest of time. So just like gcloud run deploy is my favorite command, this is my second favorite. Gcloud run jobs execute, and then the name of the job. So we'll run that. We'll wait a few seconds, because again, think of this as like we're just manually executing that job. You could think of this as Cloud Scheduler. You could think of this with workflows. We're just telling it, hey, go run this job. So right now, it's currently executing. And if we go to this link in the Cloud Console, we see that it's running. I just want to show you configuration, see how it's similar to a Cloud Run service. But again, there's no HTTP server waiting for requests. It just runs it to completion. We go here to Cloud Run. You see services. So here are all your Cloud Run services. And now here are the jobs. And we see that it's succeeded. But I want to make sure I show you all the video. So I grabbed this. So in the code lab, it's a 2-minute video. I grabbed it from the samples for the Vision API for in the cloud storage bucket that's publicly available. And but this is an 8-second version. All right. So immediately starts off the first second, white background. What is Google Cloud Vision API? Question mark is in text. And then there is a speaker wearing a red shirt. And in the upper left-hand corner, it says, what is Cloud Vision API? 8 seconds. It's done. Now if we go back to Cloud Run, and we go to the service, or yeah, let's go to this one. OK. And then we see video describer job. OK, that's what I call it. And succeeded. All right, so that was the task. And logs. And here, when we scroll up, I zoom in. You see timestamp 1, what is Google Cloud Vision API, question mark, is written on a white background. and then so on and so forth for the other scenes that it detected. And that concludes demo 3. So now to wrap up the presentation, go back to slides. All right, so the recap. You saw an overview of how you can let Cloud Run handle your auto-scaling needs while you focus on your code. So in demo 1, you saw how they incorporate Gemini into a chatbot on Cloud Run, and how they use the Google client libraries to handle authentication to Google APIs for you. In demo 2, you saw how you can use function calling, so your large language model isn't frozen in time. And in demo 3, you saw how you can use specialized Vertex AI APIs for specific tasks. Cloud Run is offering specials right now, so feel free to scan this code to receive personal guidance from one of our experts. These QR code links, these CodeLab links, they're the same as the QR code that you saw throughout this talk. They're just written out in short link form. We have lots of other Cloud Run sessions. If you were looking for a LangChain and how to ground your LLM in your own data, please check out tomorrow's session, Dev 253 tomorrow. This is a customer session with L'Oreal and my teammate Vitsa, who taught me literally everything I know about Cloud Run, is doing the demo, so please check this out. And then also on Wednesday, there's Dev 205, the latest in Cloud Run. And also on Thursday, there's a customer session with Ford Motor Company to hear their story with using Cloud Run. I greatly appreciate your feedback. Thank you for being here. I really love what I do, and I hope I've encouraged you to go out and explore what's possible with Cloud Run, maybe for an idea you have, or maybe for your next business idea you want to try. So I know thank you. Yeah.